that was 21.6. So t equals 21.6 seconds. So that's what we're going to plug in here, right next to k, 21.6. Okay, so now on my calculator, what I would do, I would plug in 12.5 divided by 100, which gives you, which I can't think, I don't think you can see this. Ah, there we go. Gives you 0.125. So that means that I need to take the natural log of 0.125. I haven't done anything with that other side yet, so I'm just going to carry that down because I haven't done anything with that yet. I just want to get this to be simplified. So I took 12.5 divided by 100. I got 0.125. Now I'm going to say, I'm going to hit this LN button, and then I'm going to write 0.125, and then close that parenthesis, and equal. And I'm going to get this fantastic negative number that you can't see on your screen because it's too dark. There we go. But it's a negative 2.08. And that equals a negative k times 21.6. Can we find k now or get k by itself? You should be saying yes. How can I get k by itself? I can divide both sides by 21.6. So if I divide both sides by 21.6, I'm going to get 2.08 divided by 21.6. That gives me 0.096, and that's a negative. That equals a negative k. So really, k would just equal, because two negatives, they're both negative, so it would both be like they're positive. So it'd really be k equals 0.096. So now we have k. So now I could find my half-life, because I know up here, half-life equals 0.693 over k. Well, I just have that number, it's a constant, and I know what k is now, so I could find my half-life. So let's do that. Let's find our half-life. My half-life would be 0.693 over k. Well, we just solved for k. We know that k is equal to 0.096. So we're just going to plug in that value underneath here. Now, if we divide 0.693 divided by 0.096, we get 7.22. So t half equals 7.22. So that means that this went through roughly 7 half-lives. Okay? So you have solved your problem. It takes a lot of steps. It's pretty lengthy, and that's how some of these problems will be. So let's do another one just to make sure that we are okay on this. Guys, on your next one, we have thallium-208 has a half-life of 3.053 minutes. So I know that the half-life of thallium is 3.053 minutes. I want to know how long is it going to take for 120 grams to decay to 7.5 grams. So in this one, I have a half-life, I know a remaining amount, I know an original amount. I'm actually trying to find time in this case. So let's write our equations out. We know that we have the natural log of the amount remaining over the original amount, and that equals a negative version of your rate constant times time. I also know that half-life is equal to 0.693 over k. So those are the two formulas that I know that I can use. So let's write out also what we have. We know that half-life, t half, equals 3.053. I know that my original amount of material is 120. So that means NO equals 120. I know that the remaining amount should be the 7.5 grams. So NT equals 7.5. and I want to figure out time. I really, really, really want to try to figure out time. So my goal is to solve for just t. Now again, what are you missing in this case? You're missing k. You're missing your rate constant. So again, in this problem, we're going to have to utilize both equations so that way we can figure out k and we can figure out time. So I don't know time, but I could find time because I know half-life. So I know half-life, that's just a number that's constant, so I could figure out k. Once I know k, I have everything that I need to plug in here to figure out time. So let's do that. Let's first figure out what k is. So I have my half-life equals 0.693 over k. I know from the problem that my half-life is 3.053. So let's write that out. I know 3.053 equals 0.693 over k. Well, I don't like k in the denominator. It makes it a really sticky situation. So I need to get it out of the denominator. And how I do that is I'm going to multiply both sides then by k. So if I multiplied k here, those cancel out. So k's are gone. So now I end up with k times 3.053 equals 0.693. And I can get k by itself by dividing both sides by this 3.053. Those cancel. I'm left with k equals, let's see, your k should equal 0.693 divided by 3.053. That gives me 0.23. So my rate constant here is going to be 0.23. So now I know my k, I know original amount, I know my remaining amount of sample, and now I can figure out time. So let's take the next step and figure out time. So I'm going to make a new page on here, but I'm going to rewrite what we have. So we know that the equation is the natural log of nt over no, and that equals a negative k times t. I know that nt was equal to 7.5. I know that no, my original amount, was 120. And we just solved our k value, and that was 0.23? 0.23. Awesome. 0.23. So now I can figure out t. So let's just plug in what we have. We have the natural log of my remaining amount, which was 7.5. So I'm going to write 7.5 on top. And that's divided by the original amount, which was 120. And that's going to equal a negative rate constant k, which we just solved for that. That's 0.23 times time. So let's simplify this. If we did 7.5 divided by 120, we're going to get the natural log of 0.0625. And I haven't done anything with this side, so we're just going to bring it down again. If I plug in my calculator, the natural log, or ln, of 0.0625, you're going to get a negative 2.77. And that should equal a negative 0.23 times time. So now this is so simple that all you need to do is get time by itself. So to do that, I can divide both sides by this negative 0.23. So let's do that. So divide by negative 0.23, divided by negative 0.23. These negative 0.23s will cancel. If I take negative 2.77 and divide it by a negative 0.23, we will get what our time equals. So 2.77 divided by 0.23, that gives me 12.04. So my time is 12.04. Yay! Okay, so you have successfully done 2 examples of these half-life problems. I try to go through those as much as you can. If you have questions on them, then post those questions to the blog. And bring those questions also with you to class. If you really are struggling with it, though, post something to me on the blog so that way I can try to walk you through it. If not, you really understand it, and you may just have like a little tiny little minor question, then just bring it to class. But those are our examples for half-life calculations, and I'll give you a little piece of paper tomorrow where you can practice 3 of those. And I'm going to continue this in 1 second where we will start talking about ionic bonding and ionic compounds. So I'll be right back.